It definitely changes your life. It helps you establish relationships that are really tighter because you already have a lot of things in common in the way you think, work, want to change the world around you.
As you get involved in IEEE, you really get a sense that you want to give back and to grow the community that you have.
I think there's a natural intersection between IEEE and its role in promoting the emergence of new technologies and entrepreneurship.
IEEE was a great channel to get to connect with professionals in the field. You never know what's going to happen when you meet so prominent people that are foreseeing the future.
What has IEEE brought me? I've worked full-time in power system automation, which we call smart grid, for over 41 years now, full-time. And the job changes I've made were through industry friends that knew of opportunities that I wouldn't have known otherwise and opened up the door for me. And many of these industry friends I met through IEEE.
What other place can you try to take a risk of doing our presentation skills and bringing in somebody from industry to talk to other scientists and engineers? I've been a member of IEEE for 25 years, and I still talk and mentor about this to this day.
IEEE has given me opportunities to network in terms of getting to know the leaders in the field, and also has provided an outlet for those leaders to know what I'm doing. So it's been good for both of us.
Given the world that we're living in now, where everything is pretty much about the internet and about connectivity, it's actually a good time to be an engineer and to be a telecommunication and networking engineer.
We know it's about the dynamics between people and people groups where our future is. And engineers can facilitate that, but they don't have the answers. It's the answering of us together as a community, not as engineers alone. So engineering is not going to solve the world, but it's going to facilitate that problem solving and getting together.
At IEEE, we believe technologists are the key drivers of tomorrow's innovations because we can really do what IEEE's motto states. We can advance technology for the benefit of humanity.
I always wanted my education to mean something more than just, doing a day job that pays my checks. I wanted to see how my background in engineering and other things could have an impact that can make somebody's life better.
Being able to connect our members with younger students and engaging them to emphasize that it is important, that what they are pursuing in their STEM careers is truly going to be the next thing that affects all of humanity, because all technology that we make is affecting people, and it's not just IEEE members, it's everybody.
Si je devais résumer la Bibranche avec vous aujourd'hui, je dirais que c'est d'abord des rencontres. Des rencontres entre étudiants appartenant à différents laboratoires, différentes entreprises, mais aussi avec des chercheurs venant du monde entier. Nous accueillons tous les étudiants appartenant au domaine de l'électronique, au sens large. Nous donnons la possibilité à ces étudiants membres de créer leur réseau professionnel dans des domaines qui leur tiennent à cœur. Être membre Bibranche, et donc membre I3E par extension, cela vous donne beaucoup d'avantages. Notamment, vous aurez accès à une grande librairie d'articles de conférences en électronique, mais aussi à l'actualité des dernières technologies et aux événements organisés par les entreprises de pointe. Mais avant tout, cela vous permet de faire partie d'une des plus grandes communautés scientifiques mondiales. Et tout cela pour seulement $20. Sur le campus bordelais, on organise des événements à peu près tous les mois, sur place ou sous forme de virtual event. au cours desquels on a des invités tels que des chercheurs. Mais on permet aussi aux étudiants du campus bordelais de transformer leurs projets d'études en projets I3E, en ayant un soutien financier, et nous les accompagnons aussi dans l'écriture d'articles scientifiques afin qu'ils aillent en conférence par la suite.
Être à la Bibranche, c'est faire partie d'une équipe dynamique et soudée pour promouvoir la science.
Pour moi, la Bibranche, c'est l'occasion et l'opportunité de changer son quotidien d'étudiant. C'est l'occasion d'organiser tout plein de choses, des séminaires, des journées thématiques ou encore des concours technologiques autour de divers sujets scientifiques.
Rejoins la Bibranche.
La Bibranche.
Donc rejoignez tous la Bibranche.
Únete a la Bibranche.
It's a Bibranche, bye.
Unisciti alla Bibranche.
So we have 16 people connected. Okay. Hello, Professor Sekine. Bonjour.
Bonjour. Je suis désolée d'être en retard.
No problem. It's totally understandable. We are happy to have this event with you today. And as I've said, that we are live on YouTube, so all our students can watch this event and contribute if they want. And also, we have students connected to the Zoom, so the one that can directly interact with the Japanese student. So we are very happy to have this event between Bordeaux and Meiji University. So I've said what I have to say. Now, Professor Sekine, I'll let you give the instruction and make the introduction about this event.
Thank you. Hello, everyone. My name is Kaori Sekine. Nice to meet you, everyone. This is a third student workshop between Meiji and Bordeaux INP. And thank you for Francois to organize this workshop. And this workshop, first part, French student will be prepared to the Jeopardy. And the second part, part 2, will be prepared by Meiji University students. So let's enjoy and please enjoy this workshop. Thank you. And let's please start the Lauren. He's a facilitator.
And on the French side?
Yes, French side. I can't hear you. Francois, can I hear me? Oh.
Demander qui manage côté français pour dérouler le Jeopardy.
Laurie est à côté de moi, elle gérera les slides.
D'accord. Et l'animateur, c'est vous qui parlez, donc.
Okay.
Because we will start on the Bordeaux side, so I leave the floor to the French student to start the Jeopardy.
Je peux pas rester connecté.
So Gila, you have to present the rules and how it works for our Japanese colleagues.
Okay, I'm gonna see one thing with Laurie. Just 1 minute, please. Sorry. Okay. So there is 6 parts. Yeah. Do you hear me? Can you hear me?
Yes.
Okay. So as I understood, there are 6 parts on transistor MOS, trench culture, operational amplifier, history of electronics, modulation, and last analog filters. So there are each part is composed of 5 questions, and you will be able to answer those questions properly. Okay, so we are gonna begin with the MOS transistor. So first one. So first question. What do the letters MOS represent? Does have someone an answer? Do someone know?
It represents.
You can speak.
Okay, so it
Sorry, yeah, just a technical problem. Is okay. 10 seconds.
Alors du coup, ça marche?
Yeah, you can speak.
Okay, sorry. Okay, so the letter represent metal oxide semiconductor.
Okay. It's okay. Yeah. We are gonna check it. Metal oxide semiconductor. It's okay. So next question. What are the 3 ports of the MOS transistor? Does someone have an idea?
So we can ask our Japanese colleagues and students to raise the hand, activate the camera, and do not be afraid to give an answer. We are waiting for someone from Japan to answer this question.
Okay, so do you have an idea? The 3 ports of the MOS transistor. Maybe one of them?
Maybe, Kaori, you can ask Japanese students to, in Japanese, to
Yes,
answer
yes,
the
yes.
question.
And 日本の学生さんたちカメラちょっとオンにして参加したいと思うんで、ちょっとカメラオンにしましょう。皆さん。はい。カメラオンにしてもらって、どうで、多分皆さん、答えが分かったら、手挙げるマークありますね。手挙げるマークを押してください。で、答えが、英語じゃなくても、Google 翻訳機を使ってもいいですから、それで答えて、日本語で答えても大丈夫ですね。日英にしてみてください。大丈夫？これですね。モスの三端子なんですかっていうのを多分皆さんわかると思うんで、わかった人ちょっと手挙げてください。京島くんとか言って。
はい。3-port drain source gate.
Okay, we are gonna check it. Yeah. Source, drains, and gates. That's right.
Right.
Okay. Next question about the MOS transistor. What are the 2 types of MOS transistors? Does someone have an idea? Someone? The 2 types of MOS transistors. Sorry? No, no one has the answer.
運野くん、どうぞ。
Yes.
Yeah.
And most transistor negative and positive.
Okay, we are gonna N MOSFET canal N and P canal. Positive, negative. Okay, that's correct. Next question. So, what are the functional regions of the MOS transistor? Maybe a French student can answer it this time. Does someone have an idea? Maybe Luis, do you have an idea?
Yeah, I think it is saturated and linear.
Okay, we are going to check it. They are linear, saturated, and there is also the blocked way, but yeah, linear and saturation. Yes, that's correct. Next question. What do the letters FDSOI represent, and what is the name of the edit port mode? It's a hard question, yeah. Someone? No idea? No?
Let's wait an answer from Japan. So
Okay.
I can see that we have many students connected, like Takuto, Koichi, Natsuki, Hiroshi, Hiroki, Ruizo, Haruto. So, Milan, do not hesitate to ask each of them, namely, what they think about the question.
Okay, I will do that. My job. Okay, maybe another one. Takuto Kyojima, do you have an idea?
I have no idea. What?
No idea.
What's the FDSOI? I don't know.
Yeah, that's a pretty hard question. We are gonna check the answer maybe. Okay, the answer is fully depleted silicon on insulator body biasing voltage. Yeah, this was quite hard. We can be sure of that. Okay, so the MOS section is finished. Now we can continue French culture, maybe, with the first question, quite easy, I think. Which French monument is the most famous around the world? The French monument that is the most famous around the world. Maybe someone have an idea? If you answer this question, you will
So
not be
only
asked
the
to
Japanese can answer
the
those
order.
questions. Only the Japanese can answer those questions. It's really important.
It's quite easy for us. Okay. Maybe may I ask to? I will check. Hiroki Yajima. Hi, do you have an idea?
Eiffel, Tower of Eiffel. Oh.
He said Eiffel Tower.
Okay, we're gonna check. Yeah, the Eiffel Tower is correct. Nice. Okay, next question. So the next question is, what is the name of the French sorry, what is the name of the bread French people always eat? Sorry. The name of the famous bread French people always eat.
And we want the French name.
Yeah, we want the French name. It's quite easy question, I think. It's like a French cliché. Maybe someone has an idea. May I ask to Koichi Subway, do you have an idea? Hi.
Baguette?
Yeah, that's correct. Okay, hop. The baguette. Yeah, that's not a myth. We all eat baguettes. It's not a myth, and we love it. Okay, next question. Oh, sorry, it's not that. Yeah. Okay. Next question. We were in clichés, and we are gonna carry on clichés. What are the French cliché clothes? Does someone have an idea? What are the French cliché clothes? May I ask to someone? No one has the answer, if you don't mind. Maybe Natsuki Ando, do you have an idea? Hi.
No idea.
No idea? Yeah, this question is not as easy as the last one. So no one has an idea? Maybe we can check. Yeah, well, I think we are going to check the answer. Okay, the French cliché is that French people are always with a beret and a striped shirt. It's not true. We are not like this always every day. We never use a beret, and it's most common with the striped shirt, but not always. Okay, we are gonna go on. Okay, next question. What is the name of the president of the French Republic, actually? What is the name of the president of the French Republic? Okay. The name of the president of the French Republic. Does someone have an idea? May I ask to Ryozo Fukuda? Hi.
I have no idea. No.
Okay. No problem. I will ask to someone else then. can I ask to Hiroshi Kobayashi?
We have just lost the connection, no worries. So, Hiroshi, do you know the name of the French president?
Okay, we are experiencing an internet problem.
Yeah,
So
no problem, no problem, Louis.
Give ici to Guilain.
Yeah, no problem.
No.
So the question was, what is the name of the French president?
I'm sorry, we have some connection problems in here.
Okay.
Don't worry, it will be okay. So
the question is still open. What is the name of the French president?
Emmanuel Macron.
Yeah, it was.
Bravo!
Yeah.
Congratulations.
I think it's quite hard because not really famous. Oh, I'm sorry.
Yeah, well,
I'm relogging.
Just wait. Yes, so just wait for the Jeopardy to be fixed. It's really important that in France we do not know the name of the French emperor, the Japanese emperor, or the Japanese prime minister. So congratulations to know the name of the French president. And we know that you have a new emperor in Japan. This is the only thing we know. Okay, so the Jeopardy is back.
Yeah. So we had some connection problems. Yeah, it was Emmanuel Macron. Yeah, you got right. So nice. Correct answer. And one question. It's quite hard, but if you know a little bit where we are studying, you maybe can have an idea of the answer. So the question is, what is the French city which produces world-renowned wine? If you know where we are studying, it can be a clue. Okay, so does someone have an idea? It's quite hard. Yeah, if you have an answer, yeah, you can just speak. No problem. I can see you.
Guilain Aruto has written.
Yes.
Oh, okay. Carry on, Aruto. Hi.
It is Bordeaux.
Yeah. Okay, we're gonna check, but I think you're right. I really think you are right. Yeah, it's Bordeaux. Yeah, the city where we are studying actually. Very nice city. So we finished about French culture. Now we are going back to electronic with the operational amplifiers. And the first question is this one. What are the main active components of an operational amplifier? For this part, French student can answer too, if you want. Okay, so the main active components of an operational amplifier. I can ask to French students like Maxon, Louis.
Yeah, sure, I can answer. So there are many stages in an operational amplifier, but they are mainly composed of transistors.
Okay. Cool. Yeah, it's made of transistor. That's the right answer. Nice. Okay. Nice, Maxence. Next question. Next question. In here, still about operational amplifiers. Maybe we can ask to a Japanese student this time if the positive voltage is superior to the negative voltage. What about the output voltage for the operational amplifiers? Does someone have an idea? No one is answering. Okay, I will ask someone then. So, Kochi Subway, do you have an idea? Hi, again.
Diode is plus voltage. Sorry, I have no idea.
Okay, we are experiencing internet problem again. Okay, so just give us a few seconds to reconnect. So yeah, I think the answer for the last question was Viot to the positive supply, because a positive voltage in input, so the amplifier gives a big positive voltage in output. So I don't know if it was what you were seeing, because we got cut at when you answered the question.
Okay, coming back.
Okay, so Guilain is close to going back.
Hi again. I'm sorry for the problems. I think this time it's gonna be fixed. I hope it's okay. I don't see the answer. Okay, so I think Luis answered right. Luis answered right because it's the out equals the positive way. So there is a plus. So yeah, Luis, you got right. Okay, next question. Next question. This time I think I'm gonna ask a Japanese student. So can you give me one drawback of an operational amplifier? One main drawback of an OPA. Does someone have an idea? Natsuki Hando, hi again. Maybe you have an idea? I heard you, but not anymore. Okay. Hi. but maybe you have an idea of the drawback an operational amplifier can experience.
Hop là. Donc ça c'est bon. Alors, je vais les modifier vite fait. Alors, on modifie la taille des pastilles. Là, effectivement, elles sont un peu...
we can hear you. Maybe you can...
La taille que je fais.
Pierre-Marie, can you cut your mic, please? Maybe I can ask someone else.
Ah oui, ça fait 1 cm, ok. Non, j'avais pas fait gaffe, mais ça fait 1 cm, enfin 1 mm. Ce qui est énorme. Du coup, non. Ce sont les pastilles.
Ah, okay. Okay, he cut his mic. It's okay. So I'm gonna ask someone else. No problem with that. Maybe Hiroki Yajima. Hi again. Do you have an idea of a main drawback operational amplifier?
Sorry, I have no idea.
Okay, no problem. So we are gonna check the answer right now. So the answer is that all parameters change with temperature, and one other drawback of the operational amplifier are that noise even when there is no signal applied. So there is always some noise with operational amplifiers. It was not an easy question, no problem. Okay, so let's carry on. Let's go to next question. So this time, do you know of any basic circuits using operational amplifiers? For example, concerning negative feedback applications. So a basic circuit using operational amplifier, and we help you giving you an example like with negative feedback application. So does someone have an idea with that? Maybe we can ask to French this time. With my French friends, Louis, Remy, Maxime, Pierre-Marie. Does someone have an idea?
I think Remy is currently working with operational amplifiers, so he might have an answer.
Okay, I'm gonna ask Remy then.
Maybe amplifier, linear amplifier.
Linear amplifiers? Okay.
And summers, subtractors. Yeah, summers and subtractors. And yeah.
Okay, we're gonna check it. Maybe. Yeah. Okay, so the answer, sorry, is differential and summing amplifiers and differentiator integrator for operational amplifier circuits. So yes, for me, you did right, and there are many answers, but your one was correct. Okay. So next question. Next question, okay. Do you know of any basing circuits? Sorry, it was the last question. I did it once again, it's not good. Okay. Sorry, I'm sorry. It's okay. So we are gonna go on another subject, which is oscillators. Okay. We have the first questions. First question with science, more about science history. Which equation developed Maxwell? Maxwell, a great physicist. So does someone have an idea of the equation that developed Maxwell? Maybe I can ask to a Japanese friend. Takuto Kyojima. Hi, again. Maybe you have an idea.
Maxwell developed.
So you maybe the sector what you know?
So I can't say English.
Okay, no problem.
This equation.
Okay. But we are gonna check the answer directly. Maybe we will find out the rules then. Oh, okay. So the answer is equations of electromagnetic fields. Maybe that was the role you were finding out. Okay. So the answer, and then let's go to the next question. Sorry. Next question then. Whom the unit Farad for capacitors, you know, takes its name from. So another way to say it is, who is the one person who influenced the name of the capacitors unit? So does someone have an idea? Once again. Pierre-Marie, maybe? Do you have an idea?
Faraday?
Yeah, that's correct. That's Faraday. Michael Faraday, of his name. It's a correct answer. Okay, let's move on. Next question. Who invented the electric lamp? I have the answer. Maybe someone else can do this. Japanese students. Maybe I can ask to sorry, I don't really speak well. Ryozo Fukuda, maybe you have an idea?
Edison is.
Yeah.
Edison.
Yeah, Thomas Edison, yeah. That's right. Okay. Next question, harder this time. Who invented the vacuum diode in 1897? Okay. Maybe a French student? Remy, do you have an idea?
Not at all.
Not at all? Okay. No problem with that. This is a quite hard question, I can admit. I'm waiting around 10 seconds, and if no one has an idea, I put the answer.
Fleming.
You said Remy?
Fleming.
Yeah, it's Fleming, yeah. John Ambrose Fleming. It was him. Nice. Okay, let's move on. And the last question about electronics history. Who was the one who invented the electronic oscillator and regenerative feedback? The one person who invented the electronic oscillator and regenerative feedback. So I'm gonna check on Japanese student this time. Maybe I can ask to Tatsuya Ibuki. Hi.
Oh, hi, nice to meet you.
Hi, nice.
Sorry, I'm a faculty and I'm a newcomer to observe this event.
Okay.
Maybe I will attend the next event. So let me just observe today.
Okay, no problem.
Excuse me, everyone. For this event, some professor in Meiji or Bordeaux INP will visit to this event. So Professor Ibuki is one of them.
Okay, I'm sorry. Sorry.
No problem. No problem. Thank you. Thank you. I'm enjoying.
Okay. Thank you. I'm sorry. I'm gonna ask someone else. I'm gonna ask once again to Hiroshi Kobayashi. Hi. Do you have an idea of the answer of this hard question?
Sorry, I have no idea.
Okay, I think it's a hard question. No one has idea. We're gonna check on the answer right now. It's Edwin Howard Armstrong. To be fair, I didn't even know myself, but that's how we learn. Okay. So we are gonna check the new section, which is modulation. So as you can see, there is a signal right here. I don't know if you see it. So the question is, how is the signal modulated? What is the modulation type? Maybe I can ask two French students, Louis, Maxime. Louis, do you have an idea?
Yeah. So I think it is an amplitude modulation, and also maybe it's over modulation.
Oh, okay. We're gonna check on that. Yeah, that's the amplitude modulation. That's right. That was a pretty easy question. I don't know. So now we saw the amplitude modulation. We can ask, what are the three analog modulations? The three analog modulations. Maybe a Japanese student has an idea. I can't hear someone, so I will ask to someone then. Who am I going to choose? I think I'm going to choose Haruto Uno. Hi, do you have an idea? So Haruto Uno.
Amplitude and frequency.
And the last one?
Sorry, I'm not sure. Last one.
Okay. The answer were amplitude, frequency, and phase modulation. So you got quite right. Next question. What does QPSK means? So how can we represent it? How can we represent this modulation type? The QPSK modulation. Does someone have an idea? Maxence, maybe?
Yes, I think we switched to digital modulations, and it means quadrature phase shifting.
Okay.
And so we can represent it in, I would say, real and imaginary plane, and it's I would say 4 points. It's like a constellation, and each point it's about pi over 4 etc.
Okay, you're
It's
right.
the phase of the symbol.
Yeah, we were just checking, and you are totally right, Maxime. The quadrature phase shift keying, just like you said. Nice. Okay, just move on to the next question. The next question is, what are the current digital modulations used in the LTE standard? Our question 2. Maybe a French student still has an idea. Louis, Remy, Pierre-Marie. Does someone have an idea? Remy, maybe?
Maybe 64 quam and 256 quam, maybe. You're right.
Yeah, that's correct. You got right. The QAM modulations, there are many types, like 16, 64, and many others. Next question. What does OFDM mean? And how does it work? Japanese students this time. Maybe I can ask to Koichi Subway. Do you have an idea?
I don't know OFDM.
Okay.
Sorry.
No, no problem. Okay. Maybe someone else. Takuto Kyanjima. Do you have an idea too?
Okay, and I understand OFDM, but I can't say English.
Okay.
yeah, this OFDM. So, 日本語で言うと直行周波数分割多重変調方式で、this work many date on and signal.
Yeah, I think you had the idea, but it's hard to explain maybe in English. So the answer was orthogonal frequency division multiplexing. And yeah, just like you said, it was a coding of digital signals by orthogonal frequency division. So there is many subcategories. Yeah. I think you got right, but it was hard to say. The last section is about filters. Sorry, there is no transition, but there is another and the last sector with filters. So this time we are going to speak about the main types of ideal filters. Does someone have an idea? That's a quite basic answer in electronics. A French student, Luis, do you have an idea?
Yeah, I think the main type are low pass, high pass, maybe band pass and band cut filters.
Yeah, low pass, high pass, and band pass. Yeah, that's correct. Next question about filters. What does the frequency when you are 3 decibels below represent for the frequency in the filter? What does this frequency represent? I will ask to Hiroki Yajima, maybe you have an idea.
cutoff frequency.
Okay. Yeah, cutoff frequency. You got right.
Right.
The next question. What is a DC fiber for? The DC fiber. What is it for? Maxence, maybe? Do you have an idea? The DC fiber.
So you mean why do we use like a DC filter?
Well, why do we use it?
Oh, okay. Maybe you just want to cut the continuous voltage in a circuit. I don't know, to protect. I don't know the biasing of transistor. So use a capacitor often.
So.
Like, it was a filter just to. Okay, I didn't understand the question.
No problem. The DC filter is used to extract the continuous components.
Okay.
So just to take the continuous part and filter the alternative part. So let's move on to the next question. How many cutoff frequencies does the bandpass filter have? How many cutoff frequencies does the bandpass filter have? No, no one has an idea. In our Japanese friends, maybe. Or Pierre-Marie, Rémi. How many cutoff frequencies does the bandpass filter have?
2.
Okay, it's correct. Well, 2 cutoff frequencies, yes. And another question. You maybe know some high order filter name. So can you give a name? Can you give the name of the high order filter? It's a classic one. Yeah, I'm sure you saw it. The name of a high order filter. Natsuki Ando, can you hear me? Do you have an idea?
High pass filter.
Yes, for a name of high order, that's high pass filter, for example. But we also had Butterworth filters. I don't know if you know this type of filters. Butterworth, yeah. I'm sure you saw it in your classes. Okay, so all the questions were posed, and then we finished the final Jeopardy. So it was a pleasure to ask you all of these questions, and I hope you enjoyed this time. So maybe I can give the talk to the Dr. Rivet or someone else. I will just get my.
I have nothing to add. I just would like to thank you for the whole organization of this Jeopardy, and it was really nice to see the Japanese students not to be afraid and to contribute to the answers of this Jeopardy. I know that the questions were not easy, and it was great to see everyone interacting about that.
Yeah, thank you, everyone.
So now I think we can switch to the second part of the workshop. So yes. Professor Sekine.
Thank you for organization of French student. So what Sensei, do you have a questionnaire? 和田先生は準備できてますか？大丈夫でやれます？
今やるんですね。
そ
した
後に
今できたとこまででやりますか？
今いる人って全員じゃないですよ。全員、どうしましょうか。後にしますか。第2部は5人しかいなくなっちゃうか
わかりました。じゃあ、ちょっと1分待ってください。
And just a minute, we'd like to have a questionnaire for your reply. And in order to improve this student workshop. So, Wada Sensei will be shown that. So, wait a minute. He will show that.
はい、できました。
はい。
OK。
じゃあどうぞ。Please explain it. And please replay this questionnaire. And now, each of you can replay this questionnaire.
The mission of IEEE students is to deliver a common, high-quality IEEE student membership experience globally for lifelong professional membership through IEEE.
IEEE is a family. The friends you build through volunteering stay there. You really make friends for life.
Getting involved at your local student branch, your local section, and your larger region is one of the many benefits that IEEE students have. You can also apply for a variety of awards, both as an individual and as an IEEE student member of your local branch. You can also get involved in a variety of contests and competitions, including our #1 student competition, IEEE Extreme, a 24-hour global coding competition with over 8,000 students involved annually. IEEE Potentials is a premier student magazine. It provides you with the opportunity to get published and to review your peers' work as well. With over 400,000 members in the IEEE Global Network, you can get connected, find a mentor, and also collaborate with professionals in your field.
If you want to do something to impact your community through IEEE, it gives you the resources.
You can make the most of your IEEE membership by completing your profile. It allows us to contact you and keep you up to date with what's happening at the global IEEE offices. Take advantage of being an IEEE student member by collaborating on projects within your local student branch and your section with professional members. By collaborating on projects, you have the opportunity to get featured on IEEE TV. We'll see you there.
EPICS and IEEE empower students and local communities around the world to apply engineering to solve those challenges.
The IEEE Event Finder allows you to locate conferences, meetings, events, and activities in your area and worldwide. You can get involved in a variety of special interest groups as well. Women in Engineering, Standards, and IEEE Young Professionals.
YP represent.
Of course, that's when you graduate. Remember, IEEE prides itself on being your professional home. Be sure to take advantage of every
多分 except professor, 12 students, I think. So.
Okay. Yes. Now I'm closing the voting.今共有されてますか？
はい。
あ、
コメントします先生。
いや、コメントはないです。してください。
And the result of the questionnaire is shown in the screen, so you can see that for your reference. And a French student, what department are you belonging? Electrical course or communication course, or is there any development?
So for French students, which department are you belonging to? À quel département êtes-vous affilié?
We are affiliated to the electronic departments.
Oh, thank you.
Electronic in general, digital and analog.
Yeah, we are studying lots of different classes like digital, analog, and many others.
I see. じゃあ、和田先生、これでいいですか？これは終わりで。
はい、先生が良ければ。
保存はできてます。大丈夫です。保存とか、データの保存とか。
ちょっと自信がないですね。
はい。じゃあ、お願いします。じゃあ、now, let's finish the part 1. And thank you for organization of by French students. So after that, we are going to start the second part. Is it okay, Francois? Okay?
Yes, it is okay. With pleasure.
じゃあ始めましょう。じゃあ始めます。On y va. Merci de nous joindre de troisième partie troisième partie, non. Merci de joindre de cette troisième atelier d'étudiants aujourd'hui. 皆さん、今日は、3回目の学生交流会に参加してもらってありがとうございます。Dans cette deuxième partie, on va parler dans langue maternelle. 第2部では、それぞれ母国語で会話してもらいたいと考えています。Le but de deuxième partie est pour encourager les étudiants qui s'intéressent d'échanges avec l'étranger. この第2部の目的としては、海外の学生さんたちと交流したいなって興味を持っている人たちが、楽しく過ごせるということを目的にしています。Donc, pour mieux comprendre, on va discuter en langue matérielle à l'aide de Google Traduction. なので、お互いをよく知るために母国語を使って Google 翻訳の助けを借りながら会話をして楽しんでもらいたいと思っています。はい。今日はですね、aujourd'hui, les participants de Bordeaux parlent français et ceux de Meiji parlent japonais. 今日は、ボルドーの学生さんたちはフランス語を喋ってますし、日本の学生さんは日本語が母国語の人が集まってもらっています。では、始めたいと思います。On y va. Cette partie, 春と、ひろき、ひろき de Meiji Université, sont les animateurs. うんのくんとひろきくんが、司会を務めることに、なります。Voilà, on va se commencer. うんのくん、矢島くん、s'il vous plaît. うんのくん、矢島くん、お願いします。
本日司会を務めます。うんのです。よろしくお願いします。
Je serai le modérateur aujourd'hui, alors merci.
これでも始めてもいいんですよね。
大丈夫ですよ。始まってますよ。聞こえてます。
今回は日本の学生とフランスの学生2人組のペアとなって簡単なクイズを解いてもらうことをします。
Cette fois, nous aurons une paire d'étudiants japonais et des étudiants français à résoudre un quiz simple.
まずは今日の流れを示します。
Tout d'abord, je vais vous montrer le flux d'aujourd'hui.
今回のクイズは、2つのセクションに分かれています。
Ce quiz est divisé en deux sections.
一つ目はシミュレーターを、失礼しました。一つ目は音を聞いて違いを見つけるということです。
La première est d'écouter le son et de trouver la différence.
二つ目はシミュレーターを用いて実際に聞いた音を作成することです。
La seconde consiste à utiliser un simulateur pour créer les sons que vous entendez réellement.
では、まずクイズを始める前にペアとなる学生同士での交流を少ししたいと思います。
Tout d'abord, avant de commencer le quiz, j'aimerais avoir une petite interaction entre les élèves en binôme.
自己紹介の時間を約10分間取ります。
Prenez environ 10 minutes pour vous présenter.
ここに示した表の通りに各自ブレイクアウトルームに移動してください。和田先生、できますか？
一人見つからない。I cannot find the Monsieur Antonio Curuzzi, the student from the French side. Who?
Galaxy.
Okay, if he's not here, maybe he can be replaced by someone else.
So the Galaxy S8.
Yes, it's me.
Okay.
Okay. Yes.
Okay, I finished the setting. Can I start the session?
Yeah.
Okay. Sorry, but
先生は振ってくれる感じですか？
はい。
各自じゃなくて振ってくれる感じですか？
うん。
了解です。
します。はい。OK. I start the breakout room.
では、ブレイクアウトルームに振るので各自移動してください。
Veuillez vous déplacer par vous-même, car ils seront.
振ったのかな？なんだね。
安藤君大丈夫か？
はい、行きましたね。
ピエール・マリーさんっていうのは、今回参加してくださった人なのかな？
聞いてみてください、今ここに。
ピエール・マリー・エティシー
Oui.
Ah, tu peux aussi joindre cette deuxième partie?
OK.
あ、じゃあどこか入れてあげてもらっていいですか、和田先生。
Pierre-Marie speaking Japanese, in fact, so.
Oh non. J'ai entendu mon nom. I heard my name in Japanese. No, no, I can speak very few words in Japanese, and I heard my name when you speak in Japanese, but that's all.
Yes.
I mean, I prefer to be sure that to.
じゃあ、どこから和田先生送れますか？
言っていただけばどこでも。
どこがいいかな？じゃあ、京島のとこにしよう。
はい、
ルーム5。Je vais vous envoyer ça le 5. よし、これでいい。はい。これ何分やるんでしたっけ、うんのくん。
10分ぐらいってことにしてますが。
10分経ったら戻すのね。
そうですね。
共同ホスト関根先生と、お二人、先生たちに与えてあるので、必要に応じて使ってください。
動けるってことね、自分が。
そうですね。そのはずですね。あと、全員にメッセージを送るときも、私でも先生にでも言ってもらえばいいと。
わかりました。じゃあ、伊吹先生も、我々は、移動してみてもいいと思うんですけど。
そうですね。はい。
フランスは
So, Francois.
Yes.
May I introduce myself?
Yes, sure.
Nice to meet you.
Nice to meet you.
So, my name is Tatsuya Ibuki from Meiji University. So, I'm almost a new faculty of our department. I just joined this department last year. Just 1 year ago. So I'm a newcomer of this department, and I'm very interested in this international event.
Okay.
So I asked Kaori to join this event.
Okay. So thank you very much for your introduction. So it's nice to meet you as a colleague here. So I will introduce myself. I am a professor at the electronics department since 10 years at Bordeaux Institute of Technology.
Wow,
and I am also the director of the international office of our engineering school. So that's why I'm really interested in interactions between Japanese students and French